Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, in our previous session we have discussed the reliability of the questionnaire, and there you have learned how to use the Cronbach's alpha test for the purpose of reliability. And now I'm focusing on the validity of the questionnaire results. As you know, we have a different number of constructs in our questionnaires related to the bigger concepts or abstract concepts such as social media and the consumer loyalty. And our purpose research here is just to collect the data on the social media and consumer loyalty. In both of these variables, social media, which is our independent variable, and consumer, which is dependent variable, they are abstract in their nature. Why? Because we cannot directly observe and collect the data on them unless we break them down into measurable and observable items, unless we operationalize them, right? So that's why related to the social media reasons, we have number of different constructs such as the social media engagement and perceived content quality, and we have the trust in brand social media and some other variables, and they are indeed our independent variables related to our bigger abstract concept. And these constructs, which are the abstract concepts, we cannot measure them unless we just break them down into the number of observable items. And this is what is called operationalization reasons, right? So the bigger concern reasons in the development of questionnaire is that we should make sure that the items we incorporate to measure the construct variable or construct concept reasons that should be reliable and valid. So we have just discussed the reliability, and simply by reliability we mean that all different items we have, they should produce similar responses, right? For example, if any of the respondent is just indicating the higher social media engagement level in the option number one, right, just indicating he is strongly agree, but immediately he's just showing he strongly disagree in the option number two. And this is just kind of counterintuitive, not acceptable. I would say not logical. If you're really measuring the social media engagement, and one item is indicating that the respondent is having the higher level of social media engagement, and then the second option is kind of indicating that he is having a lower level of social media engagement, this is just as kind of inconsistency, not acceptable in the development of questionnaire research. You cannot really measure the construct. It means there is some issue in the questions you have just drafted here, right? So this is what we mean by consistency reasons. All questions should produce similar responses. By similar, we do not really mean exact responses. For example, if the respondent is just indicating the higher social media engagement, checking they strongly agree, so it's more likely he is just at least showing that he is agree in the second option, in third and fourth in this way. Right? This is just what is called the consistency. Okay, and the second concern reason, that is validity, right, users? Okay, and validity, we just try to make sure all these items we have, they are really and truly measuring the construct we are intending to measure, users. If three of the items they are just measuring and asking about the social media engagement, and one is just asking about the motivation or commitment, or you can say the satisfaction level, so it's kind of not related. Why? Because each and every item should truly and really just relate to your the main construct, right? So if there are kind of questions they are not related, not really measuring your the construct, you can say there is less validity, and that kind of question should not be just incorporated, it should be just excluded, and your question should be refined, right? Okay, once again, I'm just repeating the insurance. We have two issues. One is the issue of reliability, and another is validity. In reliability, the all items should produce similar responses, right? In the validity, all of these different items we have incorporated should really and truly just measure the construct what we are just intending to measure resistance, right? Okay, now for the validity resistance, what we are really concerned about and interested to check, that is the construct validity, right? But we have some other types of validity. I'm just briefly explaining. We have face validity, the face validity is just talking about the overall picture of your questionnaire, right? It's just making sure whether your questionnaire is just encompassing all the questions, kind of just looking, they are measuring your topic of interest or not, right? For example, you are measuring the stress level in all of the questions superficially, generally just kind of looking like they are measuring the stress level, then you can say there is face validity. There are no any elements or questions which are kind of not related, then the face validity there. So now our questionnaire response, all the questions we have, they are related to the social media and consumer loyalty. So when we confirm that, it means there is face validity, right? Okay, the content validity is talking about sufficiency of the items. For example, if I'm collecting the data on the social media and consumer loyalty, do the items I have just incorporated, they are kind of just covering all dimensions and aspects of my topic or not, right? So does my questionnaire encompass sufficient elements or items or questions that are kind of covering the broader area of my interest? I just really try to collect the data or not, right? So if yes, then you can say there is content validity. Okay, in criterion validity reasons, we are just trying to make sure our questionnaire is just standard in meeting the criteria. Simply, if you're having the one standard established questionnaire just used for the purpose to collect the data and the stress level of employees, right? And you have developed one new questionnaire, right? Then if your new questionnaire is just producing the similar response to the one which is the standard one, right? And then you can say your questionnaire is just meeting the criteria. That is just reasons called the criterion validity. And further, we have some other types related to the criteria, what is concurrent validity and predictive validity. If your questionnaire, the newly developed questionnaire, is just producing similar responses to that one which is the standard and established one, then you can say there is concurrent validity. But if it is just producing the similar responses at the same time, but if your questionnaire is just kind of having the ability to predict the future outcome, then you can say there is predictive validity. For example, you are just collecting the data on the performance of the students, and you have concluded based on the responses you have collected on your questionnaire that the students, they are not really performing well. So you're predicting that their future CGPA in the classes may be kind of low and not really high. And this prediction of the lower CGPA is just predicted based on the current responses you have elicited based on your questionnaire results, right? And then we have construct validity results. This is really important. And this is what we use for our questionnaire. And SPSS, inshallah, I learned have to check the construct validity. And by the construct validity, dear students, we mean that the items we have in the questionnaire, all of them, they are really and truly measuring the construct, what I'm really intending to measure or not, right? Okay, now in this questionnaire, dear students, when you measure the construct validity, there are 2 points which are really important. One is the convergent validity and another is discriminant validity. Okay, very briefly and simply, reasons in convergent validity, for example, in your questionnaire, if all of these items you have incorporated, they are correlated with one another, clustered together, combined, right, and they are measuring this one construct. In the same time, they are correlated with one another, right? And this is just logical. And this is what really want. Why? Because if one is strongly agree and the second is also strongly in or agree, so kind of correlation is there. If such correlation exists, measuring one construct, then it means there is convergent validity. In the discriminant validity, we mean that there should be correlation with one another, right? But these items should not be correlated with the item of different construct. For example, we have perceived content quality, so one construct is social media engagement is another construct. So you can say these items, they are correlated with one another measuring the construct, but they are not correlated with the items of another different constructs. And that is what we really want. So all these different items we have should be correlated with one another, right? But should not be correlated with the construct of different constructs we have, or with the items of different constructs we have here, right? Okay, for checking the convergent in the discriminant validity resistance, we are doing the factor analysis, right? Okay, once again, for validity, we are just doing the factor analysis. And how to do the factor analysis? Very simple, okay? Why it's called factor analysis? Very simple reasons. Look, for example, these are the number of items we have, and we group them together. They are measuring one latent hidden factor. So this social media engagement is just considered a factor, and the perceived content quality is just considered a factor. And we're just trying to make sure all these different items really just measuring this factor or not. Are these items, they are really measuring this factor or not? So we are doing factor analysis. We just identify how many items they are just combined together, right? Loading on one factors are different factors. So that's why the topic of the factor analysis is just here discussed, right? Okay, once again, in validity reasons, we just making sure there is convergent validity, indiscriminate validity, and the construct validity. Okay, how to do that? Simply just come here to the SPSS and click on the analyzations. We have dimension reduction, and here we have factor. In dimension reduction, normally response, you see all these items here by default, right? Now what I'm just really doing, I have number of different items starting from SME1 up to the TBS4, right? And just move it here into the box of variables. And what my purpose here is just I try to find out how many factors are there that these different items they are really loading on, right? How they are clustered and grouped together, right? Okay, in descriptive, just normally we may have all these options unchecked, but the only option you just need to check is that the KMO in the Bartlett test of sphericity distance, right? Okay, before the distance, when we are just doing the validity, we just try to just first we are conducting the KMO test. In the KMO, the threshold value we have that they should be at least greater than 0.6, which is a mediocre value, right? And then the middling value, and we have meritorious and marvelous value, which is really good. Okay, so if the KMO is greater than 0.6, it means it's okay. Okay, now what the KMO is just really just telling us, dear students, that the KMO is just talking about the sampling adequacy. Okay, what's the sampling adequacy? For example, we have a questionnaire, and this is the construct, and these are the different items, dear students. Okay, so you can say we can only identify and find out whether all of these different items they are really measuring the construct we have if there are share variances, if there is some correlation with one another. Okay, if there is no correlation and share variances, then you cannot group them together to find out what factor they are just really loading on. This is really important, right? If you remember, I've just given you the example of the items. For example, if you have 2 laptops, 2 tables, 3 chairs, right, and 4 mobile phones, they are different items. If I'm just asking you questions, can you just classify them, group them, and each group should be given one title and call them just a name? Okay, so if you just see that there are 3 computers, then you can say there is one group, 3 computers, they are classified, and I just call them the computer, right? One computer group, and table group, you can say mobile phone groups. Okay, if there are different items and there is some resemblance of the items there that's look alike, then you can say yes, there is share variances. But if all the items they are totally unique and different, there is no share variances, then you cannot find out, okay, which group is just related to what factors or what title in general, right? So that is why, students, the KMO is just telling us about that share variance. If there is share variance, if there is some resemblance in the number of items you have, in the variations, then you can say KMO is just telling you there is resemblance, there is correlation in shared variances, right? And if the value is just greater than 0.7, it's meddling. If greater than 0.9, the greater this value is, the better the chances of the suitability of the factor analysis. Or the more chances that you can just classify your items into the number of factors. You can just reduce the dimensions yourself, right? Okay, next, once you know about the KMO, once the KMO is just in the acceptable range, then you're checking the Bartlett's test of sphericity, dear students. Okay, and this test is just checking the significance level, whether we are just significantly different from zero or not, right? For example, if you claim that there is correlation, you can only claim that these four factors, or sorry, items, they are combinedly loading on this one factor. There must be correlation. There must be just share variances. But this correlation and share variance should be significantly different from zero. If the correlation among these item distributions is just closer to 1, it means the share variance is there, but it is just far away from 0. So the significance is just checked by the Bartlett's distribution, Bartlett's test of sphericity distributions. So very much simply, if you just try to make sure that the correlation and the share variance is just significantly different from the 0, then this value should be listed from 0.05, right? So in conclusion, dear students, have to check for the KMO and Bartlett's test. But once again, keep in mind, dear students, the KMO in the Bartlett's test is just checking the suitability of the questionnaire for factor analysis, just telling us that there is possibility of factor analysis. You can group them together to find out how they are loading on different factors, right? Okay, now how to do that, dear students? Just click here. Okay, in factor analysis, as I've just told you that you should select all of these factors and click on descriptives. In descriptive, if all these options here are unchecked, you can just check them, whatever, just if you need some data related to the correlation matrix. But this is really important. What we really need is just a KMO in Bartlett's test of sphericity. You just check this, okay, and continue. In extraction, dear students, we have number of different method of extraction, such as the principal component, and we have the principal axis filtering, dear students. But commonly, these principal component and principal axis filtering, they are used. Oh, what's the difference here? Okay, for checking the share variances, for example, if in your data, dear students, there is variance, the share variance, we have unique variance, and we have error. So if you just try to capture all of them and classify and group them and find out the factors, reduce the dimensions in such a way, then we are using the principal component. In very simple words, dear students, the principal component takes all the variance, such as share variance, unique variance, and error, right? And then compress them into fewer components. But in principal axis filtering reasons, we are only considering the share variance, and this is what we are really interested in. Okay, you should just choose the eigenvalue greater than 1, and the eigenvalue is just showing the equivalence variation, the share variance equivalent to the number of items. Okay, the share variance is just checked in the number of items, so that should be greater than 1 always, right? And just click on the continue, and the options just keep this value below 0.3, suppress the small coefficient value below 0.3. Click on continue and click OK. Okay, this is the output, results, and this output, what really important for us is just to check first the correlation matrix. And for the factor analysis, there should be correlation. If there is no correlation, it means the factor analysis is just not possible. You cannot just group the different item based on the share variances or share correlation if there is no correlation. So that's why we're just checking the ECM is just having correlation with number of different items, right? And similarly, PCQ1 is just having the correlation with number of different items related to the PCQ1. So that's why the correlation should be there. This is the first indication of the suitability of the factor analysis. And what really interested for our analysis, that is the KMO in the Bartlett's test of sphericity distributions. As I've just told you, the KMO is just greater than 0.7. It's really good. It means there is enough sampling adequacy, and the Bartlett stress is just significant, lower than 0.05. It means it is significant. There is lower sphericity, and the pattern is here. Okay, for example, when we are talking about the sphericity distance, it means if you have correlation that is just kind of showing the pattern, then it means there is correlation, there is low sphericity. But if there is no correlation, then the points are just looking like sphere or circle, like in this sphere, right, like a ball, right? There is no pattern. So when you are checking the sphericity level, and if it is just shown like there is a trend, then that's a good point. So 0.05, it means there is significant level of pattern, or you can say there is correlation which is significantly different from zero, right? Okay, so that's why in our output, these 2 points are important. So the Kaiser-Meyer-Olkin measure of sampling, yes, greater than 0.076, and this is lower than 0.05. Okay, next is you need to know about the commonalities. This is just telling you that after the extraction, have each and every extracted factor is just explaining the variations in the number of items. For example, and this is our questionnaire, and this is our extracted factor, which is social media engagement, and this underlying factor is just driving changes in these number of items. Okay, how much changes this extraction factor is just explaining in these variables. So this is just understood from the commonality. You can say 0.7, 0.8, this is just explaining SME1, SME2. Okay, the greater this is, it means the good, and the better that is, right? Okay, next is we have the total variance explained. This is really important. So if the eigenvalue, as I've just mentioned, is greater than 1, so look, this is the eigenvalue resistance, the eigenvalue, this is just greater for 3 items, the eigenvalue is greater than 1. It means only 3 factors identified. In the rest of the items, we have the eigenvalue lower than 1, and it's technically not considered. So 3 factors we have, in each factor is just explaining 37.09. For example, the first factor is explaining this much total variations in the number of items we have. And the second factor is explaining 26.7% variations in the total number of items we have. So it means there are 3 dominant factors, and yes, we have 3 dominant factors. Here we have just confirmed there are 3 dominant factors. They are really explaining variations in their respective items in our questionnaire research, right? Okay, finally, for further information, you can just check the scree plot, and this is just telling us that the graph of the eigenvalue in the factors, right? The number of items we have. So we have 3 bigger or 3 dominant eigenvalues which is greater than 0. So 1, 2, 3. So this is just indicating the 3 dominant factors since we have in our analysis, in our questionnaire, and that's really we want, right? Okay, next is we have the factor loading. This is just, we have factor matrix before extraction and after extraction. This is really important, rotated factor matrix. So this is just telling us that how each and every item is just loading on the factors. So you can say 4 items, they are just loading on factor number 3, right? And there is higher factor loading. And these 4 items, they are just loading on the factor number 2. And the another 3 items, they are just loading on factor number 1. So initially there are 3 constructs. You can say one construct is just explaining the variation in the 4 items. In there, all of them, they are just loading on that one factor. So this is clearly just telling us that all the items we have for 3 different constructs in our questionnaire, they are really loading on their respective constructs, concept reasons, right? So this is just proving that there is convergent validity. Why? Because the 3 different items we have, they are correlated with one another, but there is 0 correlation with other factors. Similarly, the 4 factors we have in the second perceived content quality, they are just correlated and just measuring truly the factor, and they are not having the 0 correlation with others. So both convergent and determinant, so discriminant validity is just confirmed, dear students. Hopefully you have learned, dear students. Just in conclusion, I'm just repeating two things you just need to know about it, and that's it. The KMO and the Bartlett test of sphericity. And the KMO is just greater than 0.06 and the Bartlett is less than 0.05. It means our question is just suitable for factor analysis. And then you're just checking the share variances and the factor loading of each and every item